Hello out there, everyone. Manny here at Area 503. I was doing some research on the NASA site the other day, and I came across this article on the ozone hole over Antarctica, and it made me really question what I know about the ozone hole, and so I decided to do a whole bunch of research into it, and I just wanted to share with you guys what I have found. All I really knew about the hole in the ozone layer was that when I was a kid, they came into our houses and made us get rid of all of our hairspray. And this guy wrote a book about global warming, which talked about it a little bit as well. So what exactly is the ozone layer? And why is it important? The ozone layer is a layer of our atmosphere that absorbs most of the sun's ultraviolet radiation. Excessive ultraviolet B radiation can lead to all kinds of effects, from the mild sunburn all the way up to skin cancer. So what exactly is causing this hole to appear in the ozone layer? As it turns out, we are. Every year as winter approaches, a vortex of winds form around the South Pole. Excess chlorofluorocarbons, or CFCs, that are in the atmosphere collect in this vortex and react with the ozone, breaking it down. You see, as it turns out, these CFCs weren't just in our hairspray. They were also in things like packaging supplies, cleaning agents, refrigeration units, and fire suppression systems. Now, CFCs have been around for a while. They were first synthesized in the 1890s by a Belgian scientist named Friedrich Schwarz. Something I found very interesting that I uncovered during this research was an American chemical corporation. We'll just call them Lamont. In the 1930s, Lamont would partner with a major United States motor company that had a subsidiary that was an appliance manufacturing company. They needed a new refrigerant that would replace ammonia and some of the other volatile chemicals that they were using at the time, and they came up with a chemical we'll just call Peon, I guess. In the 1940s, Lamont would apply for and be awarded a patent on his new refrigerant. Then, in the 60s, right before the patent was set to expire, Lamont would get crafty and slightly modify his formula and apply for a new patent. And of course, his new refrigerant was more ecologically friendly. Sometime in the mid-70s, and also conveniently when this patent was about to expire, Lamont would catch wind that some pesky scientists were about to release information that would show that his product might be interfering with the ozone layer. So Lamont again decided to modify his formula and reapply for a patent. And Lamont would hold that patent all the way up until 1988, where the Montreal Protocol would effectively shut him down. But for almost 50 years, Lamont would hold a patent on the #1 contributor to the hole in our ozone layer. So let's everybody give Lamont a big round of applause. I'm sure his shareholders will enjoy all that money.
We're not just doing this for money. We're doing it for a shitload of money.
So, enough about Lamont and his money. Here we see the ozone hole in 2017. And here where the darker shades of blue are forming is where the ozone layer is thinning out. And you can see those winds whipping around up there, and those are keeping that all locked up right down there over the South Pole. And here in the middle of November, it starts to clear up. Now, since this hole peaks in October, this next animation takes just the months of October from 1979 to 2017. And you can watch this hole get worse year after year. This is the application Earth Now by NASA. It's available on Android and iOS, and I'll link to it in the description of the video. Now, this is a very useful application that shows you recent satellite imagery. However, one drawback of the application is that Antarctica is heavily censored on most of the satellite imagery modes. Fortunately for us, the ozone layer map was left uncensored, so we can see what's going on down there. So in the center here, we're looking at the middle of October 2018. And on the left is the entire season of the hole, and you can see how it starts out lighter and progressively gets darker and darker. So unfortunately, it looks like the ozone hole is alive and well this year. So there you have it, folks. The supermassive hole in the ozone layer over Antarctica is caused by CFCs as well as other chemicals that get up into the stratosphere, they get caught in these swirling vortexes, and then they react with the ozone layer, breaking it down. Now, since the ozone layer is pretty much the sunscreen of the Earth, I think that's a bad thing. And I'm encouraged by the fact that there's folks out there like the Montreal Protocol and theozonehole.com. I'll link to both of their sites in my description, and if you want to read up more about this issue, go ahead and check them out. During my research on the ozone hole, I found some other anomalous readings down in Antarctica. So here in the average sea level model, the first thing that we notice is that Antarctica is completely blacked out. But what we can see on this map is that the warmer colors represent a higher average sea level, and the cooler colors represent a lower average sea level. And if you really look, you can see that there's a huge distortion that occurred during the summer of 2018. And I don't know what was going on down there, but it's clear that they went to some effort to try to cover up what it is. And as you can see, the North Pole and the Arctic Circle is completely blacked out as well. But what I really want to know is what's going on this side of the continent up over here. I was curious if the hole in the ozone layer would affect other levels, like carbon dioxide. And it looks like the carbon dioxide levels are fairly high all around the planet, except for this strange ring around Antarctica again, which is blacked out, but you can see around the ring that there's significantly lowers of carbon dioxide down there. Next up to check was the carbon monoxide levels, and you'll notice that there's a little bit of sensor data missing up on the North Pole. And the carbon monoxide levels in South America and parts of Central Africa are slightly higher than normal. And then we get down to Antarctica, and we are treated to a big black map outline of nothing. And finally, that brings me to the gravitational field setting in the application. Now this is interesting. It shows gravity field fluctuations between November of 2016 and June of 2017. And the hot or red areas show where the gravity field has lessened, and the cool or blue areas show where the gravity field has increased. So as you can see here, there's a significant drop in the gravitational field directly centered around Greenland. And other than that, it looks to me like most of the fluctuations occur around populated land masses, except for the polar region. Jackpot! Finally, some uncensored data on Antarctica. Look at that weakening of the field all along the Antarctic Peninsula, all the way up to Mount Tyree. And significant weakening right around the South Pole. And across the continent, by the Amory Ice Shelf, you see a significant strengthening of the field. Now, I truly don't know what to make of all this data, but it sure did seem interesting, and when I stumbled across it while doing my research on the ozone layer, I knew I just had to bring it out to you guys. Once again, my friends, I am Manny Six Fingers at Area 503. It's been fun learning something together with y'all here today. And until next time, I wish you all the best. And I am out of here to continue my search for universal truth.